So last class we learned about some key properties of discrete time sinusoids. I hope you can recall that some of the key properties of sinusoids. A discrete time sinusoid is periodic only if it is a discrete time sinusoid is periodic only if its frequency f is a rational number. Discrete time sinusoids whose frequencies are separated by an integer multiple of 2 pi are identical. These two properties are important for discrete time sinusoids. We also understood that in order to have what you call unique frequencies, you need to operate within the range pi. Okay, otherwise you may end up in a problem called aliasing. Okay, aliasing picture, in fact, I've shown you this. I hope you can recall this. Okay, look at this. So you have the original waveform, blue color one, and there is an aliasing signal, another one. Okay, so the red color one is an aliasing version of the blue color one. Aliasing is in the sense when you have these samples. Okay, these samples will give you a wrong picture about the original blue waveform. If you believe that this signal, these samples belong to this signal, but originally it may come from the blue signal, the samples. So we are talking about something called insufficient number of samples to represent the waveform. So we learn about this sampling theorem, how to sample it properly. All this once we learn discrete time Fourier transformation, then you will understand it clearly how we can do all this. But right now, your focus is on these 3 points. Okay, so understand these 3 points clearly. Then we will learn about the sampling theorem in the third unit after we learn about Fourier transformation. So at that time we will get more insights. But the one important point I said from this graph, can somebody tell this? What is that in fact you identified from this particular graph? I would like someone to open up now. Okay, today afternoon it's 2 o'clock, you can understand. Okay, it's difficult for you to be very alert by 2 o'clock, but I still expect someone to open up. What does this graph tells me? Can somebody try to put in words what I said in this from this graph? Anyone in the class? Alexander, Manikumar, Satinarayana, Gayatri, Akshaya, Aishwarya, anyone from the group? Just try to put in words. Whatever you understood, even if it is wrong, it's all right to try to express in words. Even if it is wrong, all right. What's happening here? There is a sine waveform, cosine waveform here. Okay, with a frequency of 0. Frequency of 0 means it becomes a DC signal. Okay, the samples are like this. Then gradually you are increasing the frequency. Now you get around 16 samples per cycle. Okay, for a particular what do you call the sampling rate or the sampling frequency f of s, you are getting 16 samples. Then you are increasing the frequency. What happening? The number of samples are coming down per cycle. Okay, samples per cycle is coming down. So at some particular point around at the frequency of pi, what you have obtained is only 2 samples per cycle. It means that, okay, so it means that you are rotating, moving like this. Okay. So initially you are sampling like this. Okay. Pi by 8. Pi by 8 means the sampling frequency is pi by 8 means in the sense this is 0 to pi. Okay. Pi by 8 times when you are sampling, okay, you get around 16 samples per full revolution. But when you are moving, okay, with the pi by 4, okay, then pi by 2, then pi. When you are reaching pi, almost you are getting only 2 samples per cycle. Okay, you are sampling at this point, 2 samples per cycle. Then again, when you are increasing the frequency, what's happening is the signal is becoming more like slowing down instead of increasing frequency here. See here, the frequencies are more here, but here it is decreasing frequencies. Okay, so the number of samples are not sufficient. That's why this signal is more like this one, and this one is more like this one. Okay, and the last one again you reach a 2 pi after a full revolution. So sampling at a rate of particular frequency. Okay, along with that you need to be careful about the sampling rate also. So the sampling rate is going to determine your discrete frequency. You keep this idea in mind. Okay, you can visualize this. For example, in order to sample one cycle of waveform, I need to have at least 2 samples, at least like this. These 2 samples, if I have, then I can reconstruct this waveform. So the sampling frequency, for example, what is the original signal frequency? 1 hertz. 1 hertz means 1 cycle per second. I'm sampling at the rate of what? 2 hertz. Two samples per cycle. You agree? So in that case, the sampling frequency, always remember, sampling frequency should be greater than or equal to 2 times of the original signal frequency. Then only I can reconstruct my signal. Otherwise, if it is more than that, then what happens? The signal becomes slowing down and all kinds of aliasing problem happens. Okay, can somebody repeat what I said right now? For sampling, keep this idea in mind, okay? For sampling, sinusoid like this. What is a hertz? 1 hertz. This is 1 second. Okay? 1 cycle per second with the signal frequency, cyclical frequency. Okay? Now I am going to sample this at a rate of 2 hertz. I'm going to sample it, I'm going to get these samples. Imagine this. At least 2 samples I'm going to have. Let us imagine I got these 2 samples. If I'm going to do these 2 samples, at least now it's possible for me to reconstruct this like this. Okay, so you need to sample at a rate greater than or equal to twice the highest frequency. Okay, this frequency. Then only you can reconstruct your signal without the problem of aliasing. So this idea we'll learn under the 3rd unit called the Nyquist sampling rate. With more coverage and with more insights, we will again discuss about this point. But right now, our focus is on periodicity property. Okay, so in the last class I introduced you to the periodicity property. I hope you can recall these ideas. Okay, so n should be samples, number of samples. It's going to k by n. Okay, that 2 pi k by, that is bigger omega. I got 12k, therefore n not equal to 12 samples, k equal to 1. We should have some rational numbers, then only it is feasible, I said. Because n is number of samples, it cannot be an irrational number. So that's the idea, we stop there. Now today's class, for another 30-40 minutes, I need your full attention. We will be solving some problems. So wherever you find it difficult, it's all basic problems, very basic problems. So if you find any difficulty, stop me there. Sir, I don't understand. Can you repeat? Okay? You can tell that tutorial session. So you can very well tell, sir, I don't understand. Okay, because it's only for you. The first problem, take down the kind of problems. Maybe if you have a notebook in hand, okay, try to draw these diagrams and try to think about this. Okay? So this is a problem type 1 I am giving you. Okay, this kind of problems you may get in the assignments also. So the first assignment you will be submitting soon. I will be sending you the questions. So for solving assignment, these problems will be useful. Okay. So kind of problem what you are going to get is type 1 period of problems. Okay. So here we have a step signal. U of t is step signal. Okay. When I'm going to shift this signal by 1 instant, U of t minus 1, I'm going to end up with this particular number. What is the problem given to you? I'm asking you to draw the diagram of 2u of t minus 1. Okay, so naturally in your mind, you may have already thought of this particular signal, how the signal look like. Okay, so you know that it's a step signal. The step signal, so it's going to be okay. So this is your u of t. Always remember the definitions. You should not forget. If somebody is asking you what is a step signal, you should define that. U of t, its value would be equal to 1 for t greater than or equal to 0 otherwise. otherwise. Okay, so for all these values from minus infinity to 0, the value is 0. Only between 0 to 1, between 0 to infinity, the time limit, I have the signal existing, that value is constant. Okay, so we can easily recognize this waveform. Now what is the question? The question is very clear. We have to draw 2 times u of t minus 1. So here there are 2 operations happening. One is the time shifting operation, another one is the amplitude scaling operation. Okay, this is an amplitude scale. When you are operating on the independent variable. Okay, when you are operating on the independent variable. This one you are going to shift t minus 1. Having obtained this signal, then you are saying it's going to be 2 times u of t minus 1. It means you are operating on the dependent variable amplitude. An amplitude shift. This is the time shift. Remember that. Always, all kinds of problems, you need to first of all ask, am I going to do time shift? Am I going to do amplitude shift? Am I going to do, for example, u of t by 2, if I'm going to say, okay, am I going to do some kind of scaling operation of the time? You need to keep asking this question. Okay, am I going to do some kind of amplitude scaling operations? Okay, so all these you need to think. Okay, so here is the case. Now take down the problem. Okay, 2u of t minus 1. I hope every one of you can draw this particular waveform. Because the shift towards the, this is what? This is right side direction. Okay, I'm shifting it. Okay, 1 unit along this direction. So easily you can visualize this. So if t minus 1 at it will be equal to 0. I am looking at this particular point. Then what is t? T will become 1. Okay, so naturally this 0 at 0, whatever is happening at 0th instant is going to happen at the first instant. So simply I am shifting it. Is it clear? So then what I am doing, I am going, yeah, then I am doing 2 times amplitude. Okay, 2 times I am doing. So first problem, anybody having difficulty? You can ask me to stop. Anybody having not understood the first problem? Can I repeat? All right. Okay. Second problem. So look at the second problem. What I am asking to do is f2 of t is equal to minus 2 u of t minus 2. Okay. Immediately you can see that the amplitude here is minus 2, not plus. And the other thing is that you can notice is there is a 2 unit time shift along this direction, minus. Okay. Therefore, I put t minus 2 is equal to 0. T is equal to 2. So whatever that has happened at the 0th instant, now I am going to move to the second instant. So the original signal is like this. Now I am going to move it like this. So u of t minus 2 is going to happen at t. That's what this one is. Okay. Then what I am going to do? I am going to do minus 2. I am going to multiply the amplitude by minus 2. So naturally I am going to get a waveform. At 2, the value is now 1. We are going to multiply it with minus 2. There is an amplitude change. Okay, there is an amplitude change. All right, it's an amplitude scale. Okay, so it has happened here. Let's go to minus 2. This is a minus 2. The same signal is now going up to infinity. Okay, the same signal is going up to infinity. Okay, so this is 2 minus 2 u of t minus 2. Anybody having difficulty in understanding the second problem? Can I repeat again, or you understood? Okay. Now move on to the third problem. Now what I am going to do? I am going to add f1t plus f2t. Now what I am going to do? I am going to take this signal, this is f1t, and I am going to add it with f2t, this one. So this will be quite useful, this kind of operations. You will be adding, you will be doing scaling, all those things in order to create some other waveform. Now look at this, when I add these two waveforms. So this is the original signal, 2u of t minus 1 f1t, and this is f2t, minus 2u of t minus 1. When I am adding these two signals, can you see it clearly? At the first unit, is there any signal here? There is no signal here. So that waveform is going to go like this. Till second unit, okay, it's going to be like this. No problem. But again, at the second unit, unit 2, what is happening? It's going down by minus 2. So naturally, this signal, okay, with plus 2 going in this way, it's going to pull down by 2 units. So naturally, it's going to come down. Okay, so that's what this signal is. This is going up to infinity. This is also going up to infinity. So naturally, I'm going to end up in a square pulse like this. A pulse, rectangular pulse. Okay. So a rectangular pulse like this, I'll be ending up. What I have done, I've just added these two signals. What happens if I subtract these two signals? Can you see it? If I subtract these two signals, this is 2u of t minus 1. This is minus 2u of t minus 2. I'm subtracting this. So naturally, this is going to become plus the rec. Okay, so naturally, this 2 is going to help you. Till 2, it will be 2. Then from there, it's going to become 4. Because this minus 2 is going to become plus 2. Minus of minus. Okay, so this minus 2 will become plus 2. Therefore, already 2 is here. Till this point, you can see here. And then from there, it's going to become 4. Okay, so till this point, it's already 2. Okay, 2 is there. From there, it's going to become 4. So it goes on till. So anybody having difficulty in understanding this?
Sir, in addition, could you explain, please, sir? That is square.
Yeah. Addition, this one. Square. See here, this is 2u of t minus 1. You understand this, man? This signal?
Yes, sir.
Because the amplitude is 2, it got shifted by 1 unit. That's why t minus 1. This is a time shift. This is a amplitude scale. Okay, amplitude scale. You understand? So because of that, you got a waveform like this. An amplitude of 2 and a time shift of 1. That is this waveform. Now I'm adding that way another waveform with an amplitude shift of minus 2. Okay, but it moved in the time domain by 2 units. Now I am going to add these two waveforms. So in that case, when I add these two waveforms, you can notice from 1 the signal starts. So from 1 the signal starts, it goes up till 2, no problem. Okay, then at 2, what's happening? There is a negative amplitude of minus 2. What is this amplitude here? Plus 2. There is plus 2 here. Now it's going to add it up with minus 2. Minus 2 plus 2, it becomes 0 immediately. Okay, it becomes 0. That's what the value is. Okay, is it clear? You understood?
Yes, sir.
Okay, the same manner you can work out this problem also. The same manner. Okay, there is a minus 2. Here there is a plus 2. Now I am going to subtract. There is one minus already. Minus of minus will become plus. Therefore, 2 plus 2 will become 4 at this after 2. The amplitude becomes 4 and it goes on forever. You understand? 4 amplitude is going to happen. So this signal, always remember, it is going till infinity, the same value. Okay, so you have to understand. So what happens when you do f3 of t equal to u of t minus 2? This is something little tricky. Although normally students find it this one difficult. The examination will commit error. So look at this. If I have u of t, I know how the signal exists. If I say u of minus t, I am talking about a signal which is initially like this. Okay, when I say u of minus t, it becomes like this. Okay, the signal exists only for this values 0 to minus infinity. Okay, so that is this too. It's called a more like a mirror image. Along the vertical axis, you are taking the image of it. Okay, so this is the original u of minus t. So but naturally, when you take this kind of signals, think carefully. This is u of t minus t. This is u of t. Now I am going to convert it into u of 2 minus t. So in that case, easily you can understand that this 2 minus t is positive, okay, or 0 at u of t minus t equal to 1. If 2 minus t is negative, then u of t minus t is equal to 0. You will understand this clearly. Why? Why is it so? Because how do you define u of t? U of t is going to be equal to 1 for t greater than or equal to 0. You understand? Therefore, now you are changing it to 2 minus t. Therefore, 2 minus t greater than or equal to 0 means what could be the value you are talking about? Then only it becomes 1. Am I right? Then you are talking about what? U of t minus u2 minus t is equal to 1 for all these values.
Sir,
it becomes 1. Yeah.
Sir, instead of 2 minus t, we cannot take it as minus of t minus 2, no, so it will be easy to understand.
Yeah, minus of t plus 2. You are taking that like this. Yeah, that is also. Yeah, that's all. Right, yeah. Yeah.
No, sir. It will be minus of t minus 2, sir. So we can easily understand, sir.
Minus of t minus 2. Yeah, that's all right. Yeah, that's right. That way also you can understand.
That will be easy, sir, because first is shifted and is reversed.
Yeah, that's right. So now if you look at this case, you know how to draw t minus 2. Okay, t minus 2 you can draw like this. Simply put all these values in negative. Okay, so what happens? What do you get? T minus 2, this is a signal.
Time reversal.
Time reversal, yeah, that's right. So whatever value is there, it's going to be in the reverse order you're going to get. Okay, so this is the waveform I'm talking about. Okay, are you getting the point clearly? Read out this one. So the simple way what I normally say is 2 minus t should be greater than or equal to 0. Okay, then only you will get 1 because that is a condition. So then naturally t should be greater than or equal to minus 2. For all those values it should be 1. Okay. Okay, sorry, plus 2. T should be greater than or equal to plus 2. Am I right? Yeah. Okay, t should be greater than or equal to minus t, okay, greater than or equal to minus 2, yeah, okay, plus 2, no, minus 2, okay. So t should be lesser than equal to 2, lesser than equal to, yes, t should be lesser than equal to 2. For all those values, you will be getting 1, okay. Two minus t is negative for u of t minus 2 equal to 0. Now let us take one more example. Okay. What about this example? K times u of t minus 1. U of t is the signal. U of t minus 1 is this. K times means any k you can take. K equal to 2. If you plug in, you are going to get this waveform. Okay. So that's another one waveform. Then you can multiply these two signals, f4 of t and f3 of t. What do you get? F4 of t is what? Where is f4? Here it is. F4 of t and f3 of t. So when you multiply these two, you're going to get this waveform. Okay. So we got these two waveforms together, multiplied. I'm going to end up in the waveform. Any difficulty so far? I think this part is clear. I think I made a little miss of it. Okay, a little bit carefully look into this. Okay. Okay, look at this case carefully. Easily you can understand. It's not a very difficult one. Okay, eliminate all this. So look at this case. Okay, this is u of t. Okay, always remember this u of t. This one. Then if I take u of minus t, it's quite easy. What is this? I'm going to get this. Okay. So this is what I have done here. U of minus t. So u of minus t. Okay. If I say u of minus t plus 1, what do? You're going to move this signal like this. So if I say u of minus t plus 2, I'm going to move this signal like this. That's all. Okay. So if I do u of t minus 1, that's going to be this shifter, okay, right shifter. U of t plus 1, I'm going to do left shift. The same reverse operation I'm doing, that's all. So this is your waveform for u of t, u of minus t plus 2. That's all. It's the waveform. That's what I want to do. Any doubt on this? Can you see clearly what I have a little bit of u of t, this is the waveform. Okay. U of minus t, this will be your waveform. 1, okay. 0 to 1, okay. Then u of minus t plus 2. You can clearly see the waveform is going to be. Okay, so it's going to have u of t minus 2, and you are talking about something same shape like this. Okay, then u of minus t minus 1. What is that? Okay, you can clearly see it's going to be minus t minus plus 1. Plus 1 is going to be okay. So if it is minus 1, how the shift will be? U of minus t minus 1, how the shift will be? Clearly you can visualize it. U of minus t. Everybody with me here? You can understand this, all this waveforms shifting? Anybody having difficulty?
Sir,
Yeah.
what is the graph for u of t by 2 minus 1, sir?
U of t by 2 minus 1. So normally what is the procedure? It's going to be shift and then scale now. Okay. So naturally then you, first of all you take shift u of t minus 1. What do you get? Okay. Then you scale it. For this case, this is going to be 1. Okay, this is going to be 1. This is your mu x, okay? This is your mu x. So x of t, x of t by 2. All the values will become the same value you will be getting now. Because this signal is 1 by 2. It will be t by 2.
No, sir. T will be 2, sir.
2, yeah, t will be 2. It's going to start at 2. Okay, t by 2 is equal to 1. It's going to start t equal to 2 is what will be getting. Alright? Is it alright? Right, children? Kumar, it's alright?
Yes, sir. Yes, sir.
Are you getting the point? So first you shift it and then you scale it. U of t minus 1 is x of t by 2 minus 1. You're going to get this. Okay. So anything else? Are you getting the point clearly? Shift and scale. Okay.
Sir? Sir?
Yeah. No. It is not. T by 2 will not become like this, man. See, listen carefully. See, the original waveform has to be either compressed or expanded. Okay, that's the idea. Getting the point. So in that case, when you are doing the scaling operation, okay, with the 1 by 2, it's going to get in fact expanded. So when it is expanded for a step function like this, which exists for infinity, you cannot define it. Maybe you'll check it out. You can check it and get back. Okay, so you cannot define like this. Okay. So we'll take up more examples on this and we will code this. Okay, for time shifting and scaling. But right now, just keep it in mind. This is not right in fact. T by 2, you cannot say like this. Going to get,
If you scale also, we'll get 2 only, no, sir.
huh? The scale
If
also.
you scale it, if you scale 1 means by 1 by 2, if you get 2 only, no, sir.
That's right. But how you will say it is expanded or compressed?
Sir, it is uniformly scaled, no, sir. Like if you push towards uniformly up to infinity, it will be scaled, no, sir. Since it is infinity, it will be uniformly scaled, no, sir. You cannot define that one.
Yeah, that's what. I'm little skeptical about this because this signal. See this signal. See, for example, if it is a band limited signal like this, when you are scaling, it will either get compressed or it will get expanded like this. Okay. But for this one, the signal starts at 1. Okay, it goes on till infinity. The band is infinite band. Okay, from 1 to infinity, signal goes like this. How do you say whether it is expanded or compressed based on this t by 2? 1 by 2 means naturally it has to get expanded. So when it's going to get expanded, how it looks like? Understand my point? Any answer from your end? It starts at 2, all right. T by 2 is equal to 1, I'm going to put here, therefore T equal to 2, it's going to start at 2. But what happens when it's going to get expanded or compressed? Okay, let us take this problem. This is one problem we will discuss again. Okay, this is one type of problem I'm talking about for solving the what do you call the assignment questions. Okay, so this is all right. So we add and then we multiply these two signals, and we ended up in a signal something like this. Okay. Now discrete version of versions also it's more like that. Okay, u of n plus 3, for example. I'm talking about a signal u of n plus 3. It is in the advanced shift left and the delay shift right. Okay, so this is u of n, u of n minus 3, u of n plus 3. Okay, 3, 4, 5, 6. These are all the samples would be getting. Can I see it clearly? This is the original u of n. How do you define u of n? The value will become 1 when n greater than or equal to 0 otherwise. So naturally the value is 1 here at 0th sampling instant, first sampling instant 3, 2, 3, 4. These are all the values. Now you can shift that to the right or to the left based on the same concept what we have learned for the continuous time domain like this. You understand? The same manner. The same manner you can shift and drift and right like this. Okay. Anything else? We understood everything, all these questions clearly in this particular slide. Anything you want to discuss again? If you are getting it clearly, this is one thing I told you. This also you can imagine. Okay, 2 minus t is positive or 0, then u of t minus 2 equal to 1. When it will become positive for t, okay, t should be what? T should be greater. Okay, t should be smaller. Okay, smaller than 2. Then only you can get a positive value. That's why you are getting for all those values. From 2 it goes all positive. T is smaller than positive. Okay, it is smaller than 2. Then only you get 2 minus t positive. Okay, or otherwise it can be 0 also. Therefore, t can be 2 also. So you start from 2, then it can go up to minus infinity. You can get to t less than 2. Therefore, you always get a positive value. Thereby, you are getting the condition u of t satisfying should be equal to 1 for t greater than or equal to 0. T should be always positive for getting u of t 1. That's why we are doing like this. Okay, that way you can understand this. 2 minus t is negative when u of t minus t equal to 0. Okay. So when this value becomes t, if t is greater than 2, for example, then it will become negative. T greater than 0 at 2 means all those values from 2 to infinity it becomes 0. Okay, you can visualize that way also. Understand my point? Are you getting the point clearly? What I'm saying? Anybody having difficulty in understanding this? In order to fix the range 2 here, I'm doing like this also. Okay. So otherwise, as you can do like this, u of 2 minus t. We can take it as minus t, okay, plus 2r. Like this also you can imagine. U of t plus 2 you can take, then you negative shift. That's all. U of t plus 2 is what? It's like this. U of t plus 2. And shift and scale u of minus of t plus 2. That's going to be just reverse of this. So that also is feasible. Okay, you can do both of it. Okay, fine. Any difficulty? Anybody have any difficulty on this, understanding this? Can I move? Say yes or no. All the problems are clear. 1, 2, 3. You can get problems like this. The assignment. 1, 2, 3, 4, 5, 6. Okay, 6, 7. 7 problems. All the problems are clear. Now we'll move to the next problem. Type 2 problem. Now look at this case. f1 of t is equal to t minus 1 u of t minus 1. How this signal look like? This is u of t minus 1. Okay, what is t signal? It is a ramp signal. Okay, so clearly you can visualize it. can take the signal like this. So everything is 1 unit. Okay, it goes from minus infinity to plus infinity. So it goes on like this. Okay, whatever t it's going to take from minus infinity to plus infinity, I'm going to have this signal with the unit slope. So what happens when I do a shift for a ramp signal? Okay, from t equal to 0, it's going to have a shift of 1. Okay, it's going to take 1, then the signal is going to be like this. Okay, so now I need to multiply it with u of t minus 1 in order to get this clipping. Okay, so this clipping is here. So u of t minus 1, you know what is that? This is the one. So when I multiply t minus 1, u of t minus 1, I'm going to have value like this. This is 1. This slope is now is going to be 1 only. Okay, this slope is going to be 1. T minus 1, u of t minus 1. Okay, so always remember u of t minus a, t minus a. If you multiply like this, then you can get the corresponding value shifted. Okay, so t minus a. So if this is a, I'm going to have my signal. This is your u of t minus a, u of t minus a into u of t minus a. Is it clear? So the t signal is like this. I'm shifted the t signal like this. Then multiply with u of t minus. That's the waveform we are talking about. Shifted version of the ramp. Anybody having difficulty visualizing it? Can I repeat again? You want me to move or repeat?
Again,
Alright.
please, sir.
Yeah, please. Yeah. Listen carefully. So you need to know the signal T wave. So ramp signal normally defined to be equal to T. Okay, T can be anything. Okay, T can be, it moves from minus infinity to plus infinity. Signal is like this is the ramp signal. Okay, R of T is equal. So in that case, whatever value here it is 1, here it is 1. Here it is 2, here it is 2. Here it is minus 1, here it is minus 1. Okay. So the slope is 1 and you're going to get a ramp signal like this. This is T, this is R of T. The ramp signal. So they are defined like this, R of T like this. Now when I'm going to choose what? A waveform something like this. T minus 1, u of t minus 1. I'm talking about a waveform something like this. I'm going to shift this waveform. Okay. Instead of passing through the origin, it's now passing through 1. Okay. So if that is the case, when it's not passing through the origin, you need to be careful about the slope. Okay, so you multiply with u of t minus 1. So t minus 1, u of t minus 1. I'm going to multiply these two signals. U of t minus 1, you know how it looks like. Okay, the value is 1. Okay, so this value starts at 1, not 0. So it's more like shifting the origin. More like shifting the. So when I'm going to multiply this signal with this signal, so the signal is, I'm going to get the amplitude 1. So this starts at 0 only, at 1. Okay, the waveform is going to be all these negative values going to get flipped. It's going to get flipped. Why? The signal u of t does not exist for negative values. So naturally, all these values are going to be 0 because I'm taking the product. Only the positive values I'm going to get, but it's shifted by 1 instant. The waveform is going to look like this. So, all right? You understood?
Yes, sir.
Yeah. Now proceed. Okay. Now that's the waveform I'm talking about. U of t minus. Is it all right? Now I'm going to do t minus 2 u of t minus 2. That also it is clear. Okay. T minus. What about the slope of this? Can somebody tell me what is the slope of this? What is the slope of this man?
y2 minus y into x2 minus x1.
No. Look at the signal. Whether it is what is the slope of it? The t. The signal is t. What is the slope, man? R of t is equal to t. What is the slope?
1 only, sir. 1.
1. Yeah, 1. Okay, I'm just shifting t minus 2. When I'm shifting it, I'm going to get the same 1 only. Okay, you understand? The same 1 is the slope. But between what? You need to complete, you want to take this t minus 2. Okay, this is the rise. Okay, this is a rise and this is the what do you call run. So when you're going to divide this, you're going to get 1 slope only. You understand that? Okay, so naturally you're going to take this. Okay, so that is t minus 2 u of t minus 2. the same signal, this one, u of t minus 1, u of t minus 1, shifted by one more instant. That's what this will be. T minus 2 u of t. The slope is always 1. I'm not touching with the slope at all. If I'm going to put 2t, then the slope will come 2. You understand? See, for example, instead of t, if I'm going to put 2t, what happens to the slope r of t? For t equal to 1, I'm going to have 2. For t equal to 2, I'm going to have 4. So naturally, the slope will become 2. You understand? So 2t is different from t minus 2. Remember that. These two are different. T minus 2 is a time shift. 2t is different. More like scaling it. Okay. It's scaling. It's amplitude scaling. Okay.
Then it becomes cheaper, sir, if the amplitude. Then
So
after
you get
multiplying by 2, cheaper
you
one,
get
the signal.
a steeper, exactly. That's what the meaning is. The signal is slope is increasing. So initially it was 1, 2 like that. Now 1 for 1 I'm going to have 1, for 2 I'm going to have 2 initially. Slope is like this. Now when I put for 1, if I'm going to have 2 here, then slope it becomes steeper. Okay, 2 here. Okay, you get a much steeper curve. Slope will be more. Okay, so that's the idea. Here 2t. So then you have 2t minus this signal. How it looks like? F2t minus t minus 2, u minus t minus 2. How it looks like? It's like this. You're getting the point? So the same signal, which one? This signal. Which one? Yeah, this one. This one with negative amplitude. It becomes like this. Anybody having difficulty understanding this waveform? Please stop me. Okay. All right. Now I'm going to add it with this waveform, t minus 1. So when I'm going to add these two waveforms, clearly you can see from 1 to 2 there is no waveform here. So definitely there is one slope here, 1 to 2. So that slope I'm going to get. That slope I got this, 1 to 2. Then from 2 I'm getting a negative slope of 2, negative slope of 1. Okay, negative slope of 1. Here it is increasing slope of 1. So then that becomes plus 1 slope. This is minus 1 slope. This is plus 1 slope. Plus 1 minus 1 get added up, go to a 0 slope, a constant signal. 0 slope. Anybody having difficulty in understanding this? This is little tricky ideas. Okay, normally you have a little bit think and do the problem. You cannot directly run into it. Think for a minute and then do it. Easy. See, this is a negative slope, there is a positive slope. Both are plus 1 only. In that case, when you go to add both of these slopes at point by point, it's increasing, it's decreasing. So naturally I'm going to have a constant. So till 1 I'm going to have this value and then afterwards. Alright? Everybody with me? I repeat or it's alright? Okay. Next problem. So then if I add minus u of t minus 2 with this waveform, with this one, what do I have? Then it's going to be a negative of minus 1 here. Then here you have positive 1 here. Okay, positive 1. Add these two, you're going to have 0 immediately at that point. And I've generated more like a sawtooth wave. This is very useful in some electronic circuit analysis. So I have generated a sawtooth waveform by combination of ramp and step. Okay, that's idea. Ramp plus step. So already we have seen decomposition of waveforms. Using what? Impulses. Now what I have done? I have created a sawtooth waveform using ramp and step signals. So the ramp signal is these two ramp. I added both. I ended up in like this, and then I got this way. Okay, is it clear? Now we'll move. All right, can you proceed? You understood how I got this waveform? Everyone? Yes or no? Okay. We'll proceed to the third case. So here is a case. So here in this case, in fact, we are talking about something called scaling. Again, this is another kind of problem I'm talking about. Okay, so here we have a waveform x of t like this, existing between -2 to +2. When I do 2t, I'm compressing it. Okay, so naturally, so 2t, whatever it is there here, t equal to -2, okay, so t equal to -2 become -1. T by 2 becomes, okay. So -1, 0 becomes 0, 1 becomes 0.5, and 2 becomes 0. That's the compression I'm talking about. Okay, so clearly you can visualize. For example, 2t equal to -2. If I want to know this value, what's happened? When I say t equal to -2 by, I get -2. So that is this value. Okay, so then I got 0. When t2t equal to 2, I got t equal to 1. I got this. So naturally, that's what happened. The same manner we can visualize this also. Okay, t by 2 is equal to -2, and t is equal to -4 becomes. That's why it's getting expanded like this. It's getting expanded like this. Okay, so the original signal, when t, when the scaling factor, okay, we always remember x of at, we call it. When a is greater than 1, you get what? Compression. When a is lying between 0 to 1, I got expansion, a kind of a fraction it is. Okay, 0 to 1, 0.2, 0.3, like fraction. For example, 1 by 2, 0.5. So that's the expansion. And when a is in fact a negative, it goes. Okay, you get what you call the time reversal. We call it time reversal. For example, -1, x of -t you already see. Okay, so that's the kind of thing you have to remember. All right. Now what happens? I will take another signal, x of x. It's a discrete domain. So in the case of discrete domain, little bit you have to be careful. So look at the samples 0, 1, 2, 3, 4 I have. Okay. So what is x of 2n? So you need to compute the x of 2n values. How do you compute the values? So look at this case. So whatever signal is existing, 2n, I want to compute it for the first sample. 2n is equal to 1. Then n is equal to 1 by 2 I'm getting. So this signal does not exist. Okay, primarily because n equal to 1 by 2 is not an integer. Remember, the case of discrete time domain, we are talking about integers 1, 2, 3, like samples there. So you cannot have 0.5, 2.5, 3.5, that kind of numbers is not allowed. Okay, rational numbers are not allowed. Only pure integers are allowed. So naturally, here in this case also, you can understand, okay, when I'm going to do with 2, okay, then an is more like. If a is greater than 1 means I'm going to have compression. So for example, I'm going to have 2n is equal to 2, n is equal to 1. So whatever sample is there, okay, at 2 sample, whatever value is there, 1, that's going to come at 1. You understand? Then whatever is there at 4, that's going to be there at 2. So this 3 value will not be there. Because 2n is equal to 3, I'm going to have an integer. Not going to have an integer. 3, n is equal to 0.5. That is not allowed. N equal to 0.5 is not allowed. Are you getting the point clearly? Understand this point. This idea is important. So this is my original signal. So when I'm doing x of 2n, so what I'm trying to do? I'm trying to look at this waveform in a compressed mode. So what are all the samples I will be having is a question. So then how do I do it? So take the 2n case. This n, 2n, if it is equal to this n. Okay. Then n is equal to 1 by 2 I'm getting. 0.5 is not allowed. So that signal is totally eliminated. Okay, whatever is there at 1 will not be coming. Then 2n is equal to 2i2, the second sample. Then n is equal to 1. So whatever there at 1, see whatever there at 2, sorry. Whatever there at 2, that's going to come at 2n. Okay, therefore at 2 I'm going to have 1. So that will become now the new one. Understand, new one. So then I'll be taking 2n is equal to 3. N is going to be equal to 0.5, 1.5. That's not going to be existing because it's not an integer. Then 2n is equal to 4, n is equal to 2. So whatever is that, the fourth sample is going to come at the second sample. Is it clear? No compression. Okay, definitely it is compressed. But you are missing some samples. Getting the point?
Sir,
Yeah.
if it is 1.5, we can't be assume it as 1 or 2.
No.
1.10.
Interpolation not allowed. Interpolation will do it after ADC. We will learn that. Okay, right now don't think about interpolation. Between two samples, there is nothing existing. It's completely lost. That completely lost. Good. Good question, but it's lost. Okay. You understood this idea?
Yes, sir.
Okay, now the next question. The same manner you can do it for n by 2 also. The n by 2 case, what will happen? Hey, can you see it? N by 2. N by 2, what will happen? N by 2 is equal to 1. First sample you take. Then n equal to 2. Okay, so then the first sample will not be there, but it is going to exist at the second sample. The same manner, n by 2 is equal to 2. N is equal to 4. So the second sample will not be there, but the third sample will not be there, but it is going to push to fourth sample. You understand what I am saying? The original signal, whatever sample number is there, that is 1. I am going to equate it to n by 2, so n equal to 2 is big. So the first sample will come to the second sample. Third sample will come, like that it will push. Okay, so finally you are going to have n by 2 is equal to the fourth sample I am equating. It will now move to 8th sample. Now move to 8th. So now it's got expanded. Okay, it got expanded. Okay, is it clear? Same thing, same idea. This is 2n, this is n by 2. Okay, that's the only difference. Now what I am going to do, I am going to do x of minus 2 plus 3. So what do I do? Normally waveform by 3 instant plus 3. So naturally it is going to get shifted. Okay, so why? X of minus 2 t plus 3, that's the waveform. First stage and what I am doing is x of t plus 3 is what I am doing. When I do this, okay, t plus 3 is equal to minus 1, t equal to minus 2. Okay, getting the point, 3 equal to plus 2. Okay, so this minus 1 is going to become minus 4, sir. Minus 4, yeah. Minus 1 will go pushed to minus 2. That's what this statement is. 0 will be pushed to 2, t plus 3 is equal to 0, t equal to minus 3. So 0 will be coming at 3, minus 3. And the last one, 1. T plus 3 equal to 1, t equal to 1 minus 3 minus 2. Okay, therefore minus 2. So you can clearly see there is a shift I am doing in this way. So equate it easily, you can get the points. So equate it, for example, the first point I am equating like this and knowing that t equal to plus minus 4. So that's here. And then I am equating this point. And then I am equating this point. Slowly do it, easily you can get it comfortably without committing any error. Okay, then once you shift it and then you go for a scaling. What is the scaling? 2t plus 3 I am doing. So naturally if I do 2t plus 3 for this waveform, okay, so it will become minus 2, minus 1. So that's what the waveform is. And then I go for the image, what do you call, finally reversal, minus of entire thing. So that's going to be minus of this. 3 operations. Anybody have a difficulty in understanding this? Can I repeat again? Is it all right for you? You understand this clearly? Yeah. Can I move? I'll take 5 more minutes extra today. Okay, I'll complete this. Okay. So, is it all right? Have you understood this? Everyone with me, this slide? Compression. Anything you want me to repeat? Expansion. And then both time shifting and time scaling. Okay. You can do problems like this. You take up some problems. Then fourth one. So you can get expressions like this. You'll be asked to prove delta n is equal to un minus u of n. It can be easily understood. Okay, easily you can visualize this. This is u of n. This is u of n minus 1. If I subtract these two, what do I get? I get only delta n. Only one sample. So u of n minus u of n minus 1 is nothing but equal to delta n. Comfortably you can prove this. Okay. U of n minus u of n. So likewise, the summation series delta k. Okay, for all values of k between 0 to infinity. Okay, what happens? Only when n is less than 0, I won't have any signal. I have a signal at k equal to 0. Okay, from minus infinity to 0, okay, I don't have any signal at all. So this value will be 0. Okay, and then from k equal to 0 to infinity, whatever I'm going to add, this 1 will always be there, this area. Therefore, I'm going to have 1 for n greater than or equal to 0. The same manner I can say with the shift operation also, delta n minus k. So take all those values. Delta n is equal to 1 at n equal to 0, 0 otherwise. So I'm going to add all those values. Okay, I'm going to add all those values. What do I get? You understand? K equal to 0. This, whether you understood this first one?
Once
K equal to
again,
0 when I substitute.
once
Yeah,
again.
this is cheap. Yeah. Look at this. This waveform. See, this is delta k. Okay, delta k. This is delta k. What is this? 1 minute. Yeah. This is delta k. So how this value is, k is varying from minus infinity to plus infinity. So naturally for n less than 0, okay, n less than 0 in the sense u of n I'm computing. Okay, for n less than 0, I don't have any values k. So from minus infinity to 0, I don't have any signal existing. Okay, delta k is the signal I'm talking about. Delta k means the signal value will be equal to 1 for k equal to 0. Okay, that's the signal I'm talking about. It's more like delta n. Delta n is what? Is equal to 1 when n is equal to 0. Otherwise, it will be 0 only. Okay. So now what happens? I'm going to go put k delta equal to 1. So delta equal to 2. Like that, I'll be delta k, delta 3. Like that, I'll be adding now. So all these values will be equal to 1. Okay, when I'm going to have this value. Okay, that's how I am defining it. Okay, so this u of n is going to be equal to delta n minus k. Understand this? This signal's summation value will always be equal to 1 for n greater than or equal to 0. In the sense from k equal to 0 to infinity, the signal value will always be equal to 1. Okay, the summation value will always be equal to 1. You take any value of n, it's going to be equal to 1. Okay, so maybe you can understand from this expression. Okay, I'm defining delta n is equal to 1, n equal to 0, 0 equal to otherwise. So therefore, in that case, this one can be represented as delta n plus delta n minus 1 plus delta n minus 2 like that. Up to delta, it goes to infinity. The original signal is got shifted like this. On this end, it's going to be delta n plus 1 plus delta n plus 2 like that. Up to infinity, minus infinity. So naturally, I'm going to have the complete train of pulses. But how I'm defining it? I'm defining it from k equal to 0. So from this point, I'm defining this is 0 point, n equal to 0. So in that case, my train of impulses will look like this, only like this. So what is this signal? It goes up to infinity. All these values are 1. So naturally, it is u of n. Okay, u of n is the signal I'm talking about in this case. Okay, so that's how we have to understand this. So, all right. Any doubt this? Shifted versions. It's called a shifted version. Time shifted versions of delta. Time shifted versions.
Sir,
Yeah.
any example you show for discrete shifting, sir? How to shift discrete signals?
Yeah.
Examples.
Already I told you.
Like
See here.
Like scaling with it, no, sir. How to shift?
Yeah. It's more like this. This is delta n for n equal to 0. Delta n minus 1. It's more. Understand? So this is your
Not
0 to
for impulse, sir. Like any sampled signal, sir. Like sampled signal, how we shift?
Yeah, I'll do that. I'll take some examples and show it. Okay, that is one thing we'll do. So, okay, so that's another one. So now look at the third case of problem. Determine the periodicity. For example, I have two waveforms, cos 4t to sin 8t. So you know how to compute the periodicity property. 2 pi f1t equal to 4t. Therefore, f1 is equal to 2 by pi. For the first waveform, f is equal to 1 by t, you know, time period. Therefore, f1 is equal to 1 by t1. The first signal, the time period is pi by 2. You can easily compute this. Likewise, the same manner, you can compute it for the second signal also. 2 sin 8t. Okay, that's going to be t2 equal to pi by 2. Then the ratio of the two periods, if it is going to be rational one, the complete signal as a whole is going to be these two combined signals, cos 4t plus sin. If I'm going to get t1 by t2 as a rational number, then these two signals can be periodic. Okay, that's a powerful idea. So look at this case. I got two waveforms like this. T1 by T2, I got 2 as a rational number. So if I'm going to have some pi, for example, here, or some pi root of 2, this kind of irrational numbers if I'm going to get, those two waveforms, when they are added up, even though they are periodic individually, see, remember I already told you in the last class, all continuous time signals are basically continuous time sinusoidal signals are basically what? Periodic. Okay, all continuous time signals, sinusoidal signals are periodic in nature. So naturally this cos 4t, cos sin 8t are periodic. But when I'm going to add it, I should be careful about this ratio, t2 by t2. If this ratio is not rational, then they may not be periodic when they are added together. That's the idea. The concept of the harmonics comes here. Okay, we'll learn about it, but right now just think about it. Harmonic waveforms comes here. Okay, so periodicity, when I'm going to add two sine waveforms, they may or they may not be periodic. Even though they are continuous time sinusoidals, individually they may be periodic always, but when they add together, their ratio is same manner you can work out this. Cos 4t, sin pi. 2 pi f1t equal to 4t, f1 equal to 1 by t1, 2 by pi. I can easily work out this. Okay. Then I got pi by 4. So this number pi is irrational. So this ratio is not periodic. It's a non-periodic number. Okay. Pi by 2 by 2 I got. Are you getting the point clearly? Anyone having difficulty in understanding this periodicity of continuous time sinusoidal waveforms? When you add together, you have to get this. Okay. But in the case of discrete time domain, it will be different. So you can take like this. You already did this. Okay. For every n samples, it's going to repeat. So when I do this, I'm going to end up like this. So for this to be equal, 2 pi f naught n should be equal to 2 pi k. Therefore, the f naught should be equal to k by n. It should be rational one. That's what we see. So take the first signal, 2 pi f1 n is equal to n pi by 2. Then f1 is equal to n pi by 2 into 1 by 2 pi n. I got 1 by 4. So k by n is what? K equal to 1, n equal to 2 pi f2n is equal to n pi by 8. I got this value. K by n is equal to n is equal to. So naturally both are integers. Okay, so naturally it is periodic. Same manner you can work out this one. K equal to 1, n equal to e pi, e j pi, j into 2 pi by 3 into n. j into 3 pi by 4 again. So I can work out this. Okay. K equal to 3, n equal to 8. You can easily get it. See, normally when you're going for one particular period, you have to find out the LCM of it. The least common multiple. So it is 24 is that number. For 3 and 8, the least common multiple is 20. 8 3s are 24, so I get 20. Okay, so the least common multiple is important for finding out the period of this. So we'll take up more examples in the coming classes. So we'll try to solve more problems in the coming 2 or 3 classes, and then we'll go for the next topic. Okay, so this is the first tutorial class on the various topics what we have learned so far. So for assignments it will be useful. You can follow these notes. Okay, for assignment solving assignment problems. Okay, I think I hope only somewhere I made a slight kind of a mess. I did only this. Okay, I hope it gets clear now. Okay, 2 minus t, 2 minus t, how to work out that. So that's one thing you again you have to go through it. You have difficulty, again ask me tomorrow. Then one more thing, you asked me about one question on the scaling of step signal. Okay, that we have to time scaling of step signal. I think that is quite. Maybe you'll type. You'll find out the answer immediately for that. Time scaling, huh? Time scaling of step signal. Here it is. So there is something, it is not applicable, they are saying. Time scaling is not applicable. You're clear, man. Kumar, did you check with that answer? No? Taking too much time. The time scaling is not applicable for unit step functions. Okay, that's the answer. All right, here it is given. Time scaling is not applicable. We'll check with that answer by tomorrow. It won't be working out. That's a good question, man. Kumar. Who was asked the question? First time I'm seeing this. Time scaling. Step function. Okay, I'll stop here. Anything want to discuss? All right. You understand this lecture clearly? Hello?
Sir.
Yeah. Kumar, Santosh, Narayan. Okay. So you have difficulty, please ask. Okay. So we will again discuss whatever difficulty we have. We will discuss it. It's not a big deal. Okay, you can learn from this. Okay. Bye. Thank you.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.